Hello, and welcome to today's lesson looking at acceleration. Today's lesson is a lesson found in the GCSE Combined Science course in the forces section of the physics part of the course for AQA. So in today's lesson we're going to try and define and calculate what acceleration is. So we're predominantly going to look at how we define acceleration and how we calculate acceleration. Now, in previous lessons, we've looked at the concept of velocity, which obviously is the speed of an object in a given direction, making it a vector quantity, and you should hopefully be able to explain the difference between a vector and a scalar when it links to velocity and speed. Well, in today's lesson, now we're going to look at acceleration, looking at the equation that can calculate acceleration. Now, previously we have looked at distance time graphs and velocity time graphs, and understanding how we can calculate acceleration from a velocity time graph, distance traveled from a velocity time graph, and displacement from a velocity time graph. So we're going to take those concepts forward and then see if we can work out how this links into acceleration. So, previously we've used the word acceleration. Now, acceleration is a word that we use all of the time in our everyday language. But what do we mean by acceleration? How do we calculate acceleration? What are the units of acceleration? And what causes acceleration? Now, acceleration is the change in velocity over time. So velocity is both a speed and a direction. It's got both. So an acceleration is either a change in speed or a change in direction, or a change in both. So that means that acceleration, like velocity, is a vector quantity. Now we've got the following equation to calculate acceleration. Now acceleration is the change in velocity divided by the time taken for that particular change. Now because the change in velocity is measured in meters per second and the time taken for the change is measured in seconds, that means acceleration is measured in meters per second because we're dividing the unit of velocity by the unit of time. Now we can write that as meters per second squared, meters per second, or meters seconds to the minus 2. Now we can also write the equation out as final velocity minus initial velocity over time taken, because the change in velocity is the end velocity, the final velocity, minus our starting or initial velocity. So they're actually the same equation written in different ways. Now, this equation needs to be memorized for your examination. You need to learn this equation off by heart for your examination. Now, like mentioned before, as acceleration is a change in velocity divided by time, the unit of acceleration is therefore meters per second squared. So you can write it as m/s/s, m/s squared, or ns to the minus 2. Any of those ways are correct for writing the units of acceleration. Now, a fundamental rule of physics states that acceleration is caused by a resultant force. No resultant force, no acceleration. That is Newton's first law of motion. To get an acceleration, you must have a resultant force. So, therefore, let's just recap what we've learned so far. Acceleration is the change in velocity over time taken for the change, or final velocity minus initial velocity over time taken. Now, unit of acceleration is either meters per second, meters seconds to the minus 2, or meters per second squared. So acceleration will only occur when you've got a resultant force acting on the object. So like we mentioned before, because velocity is a speed with a direction, if you change your speed, you're changing your velocity, you are accelerating, which requires a resultant force. Now, this is the most commonly thought of method of acceleration, changing your speed. Now, a negative acceleration could be thought of as a decrease in speed. Now, acceleration, though, can also occur if you change direction, because velocity is a speed with a direction, so if you change direction, you change velocity, so you accelerate. Now, once again, this requires a resultant force, because all accelerations require resultant force. Now, in this context, a negative acceleration could be the object moving in the opposite direction. So this means that if you ever get a negative value for acceleration, it could mean the object is slowing down, or it could mean the object is moving in the opposite direction. You would have to investigate further. So you can only know this by looking at the information in the question. Now, like mentioned before, to produce either a change in speed or a change in direction, a resultant force is needed. Now, we can finally link this in, okay, to something called the SUVAT equations, or the equations of motion. Now, these particular equations can be used to work out values of an object moving when it has constant acceleration. So we can only use these equations when an object is accelerating constantly, so has the same acceleration throughout this entire journey. Now, there are two equations of motion which you've got to use for GCSE physics. Now, these equations are termed the SUVAT equations due to the possible terms that can be found in the equations, because you've got displacement S, initial velocity U, final velocity v, acceleration a, and time t. So all those symbols SUVAT form the word SUVAT. Now, just to clarify a few things, S stands for displacement, not speed, whilst D, which isn't in any of these equations, stands for distance travelled. Now remember, displacement is a vector quantity. It's the straight line distance between the starting point of a journey and the end point of a journey, whilst distance travelled is just the total distance the object has travelled throughout its journey, which obviously, if it's not a straight line, okay, will not therefore be the same as the displacement. Now, there are actually two further equations of motions which are only covered in A-level physics, so we'll be talking about these in this particular video, but please note that in the future, if you do decide you want to carry out A-level physics, there's two further SUVAT equations. So equation 1 is a very common equation, and it's very memorable, hopefully, to you, because we just covered this a couple of minutes earlier. That the equation 1 is that acceleration is final velocity minus initial velocity over time. So like we said before, once we put our units in, we get our meters per second squared for acceleration, our meters per second for velocity, and our time per seconds. So we can write this in symbol form, where A for acceleration equals v, which is the final velocity, minus u, the initial velocity, over time, t. So A equals v minus u over t. Now, like I mentioned before, just a couple of minutes ago, this equation has to be memorized for your examination. Now, this is the second equation which you've got to know for an object which is carrying out constant acceleration. And that is the final velocity squared minus the initial velocity squared equals 2 times by the acceleration times by the displacement. Now, once we put our units in, we know that it's meters squared per second squared. Now, that's because it's velocity squared, so therefore the units then square. Acceleration is meters per second squared, and the displacement is in meters. Now, it's a bit of a mouthful saying all of this, particularly in this equation in word form, so I actually prefer to say it in the symbol form of the equation. V squared minus u squared equals 2as. So the final velocity v, okay, the initial velocity u, the acceleration a, and the displacement s. So v squared minus u squared equals 2as. Now, this equation, you don't have to memorize it, but you've got to be able to use it, because it's one of the equations which is given to you in your equation sheet, in your equation book for your exam. But you will probably, if you're doing higher tier paper, have to rearrange this equation to work out values in questions. So they're very unlikely going to ask you to work out a term on one side, either 2as or v squared minus u squared. They're much more likely to ask you to work out acceleration or displacement or final velocity, for example, and rearrange the equation to make that term the subject. So, just to clarify, there are two equations which we term the SUVAT equations, which you've got to use for GCSE. Equation 1, which is acceleration equals final velocity minus initial velocity over time, and equation 2, which is final velocity squared minus initial velocity squared equals 2 times by acceleration times by displacement. Now, our assumption in these equations is that the acceleration stays constant throughout the journey. It does not change. It stays exactly the same. Now, the most common example of this is when an object falls due to gravity, because the strength of gravity we consider at GCSE to be constant, to always be the same. Now, we sometimes give it the symbol small g because of gravity, and the acceleration when an object is falling due to gravity is 9.81. So if a question asks you about an object falling due to gravity on the Earth, the acceleration is constant and it's always 9.81. Now, in examination questions, it's common for you to use these equations to work out an acceleration and then be asked to work out the resultant force that causes this particular acceleration. So in these types of questions, you would use either of these equations, depending on what terms you were given in your question, to work out the acceleration. You can then work out the resultant force that causes the acceleration by using the equation from Newton's second law of motion, F equals ma, resultant force equals mass times acceleration. So to find out your resultant force, you multiply your acceleration by the mass of the object accelerating. So those are the SUVAT equations. So if we've been successful in learning today's lesson, we can hopefully define and calculate acceleration. So to summarize what we have learned so far in motion, velocity is a speed in a given direction. Acceleration is the change of velocity per second, and it's measured in meters per second or meters per second squared. The average acceleration of an object is calculated using the equation acceleration equals change of velocity over time taken, whilst deceleration is the change of velocity per second when an object slows down. The acceleration of an object can be calculated from the gradient of a velocity time graph. The distance travelled and the displacement can be calculated from the area under a velocity time graph. And then finally, you can use the following equation, which links to uniform acceleration, constant acceleration, in that final velocity squared minus initial velocity squared equals 2 times by acceleration times by distance, or v squared minus u squared equals 2as, the SUVAT equation. Thank you very, very much for listening in today's lesson. I hope you've enjoyed today's lesson looking at acceleration and the SUVAT equation. And in the following lessons, we'll look at applying this to a real-world example, an object fallen due to gravity in the Earth's field. Thank you very, very much and have a lovely day.